Have you ever looked up at the night sky, far away from the bright lights of a city? When you do, you see something truly magnificent. Thousands of tiny, glittering points of light are scattered across the darkness. Each one is a star, a distant sun, just like our own. For as long as humans have walked the earth, we have stared up at this cosmic ocean in wonder. We have told stories about the patterns we see, the constellations. We have used the stars to navigate across vast oceans and deserts. They have been our guides, our calendars, and our inspiration. Every single star you can see is a powerful engine of creation, a gigantic ball of hot gas burning billions of miles away. Some are young and hot, shining with a brilliant blue-white light. Others are old and cool, glowing with a deep reddish hue. Each star has its own story, its own life cycle, and its own destiny. Why do we study the stars? The question is simple, but the answer is profound. We are a curious species. It is in our nature to ask questions about the world around us and our place within it. The stars represent one of the greatest mysteries of all. What are they? How far away are they? Are there planets orbiting them, just like Earth orbits our sun? These are the questions that have driven astronomers and scientists for centuries. They are the questions that push us to build bigger telescopes and send probes into the depths of space, all in the search for knowledge. Understanding stars is key to understanding the universe itself. These stellar furnaces are where the elements are made. Every star, from the smallest to the most immense, begins its life in the same place. It starts inside a vast, cold, dark cloud floating in interstellar space. These clouds are known as molecular clouds or stellar nurseries, and they are the cradles of creation. They are colossal, stretching for hundreds of light years across. For a star to form, something needs to disturb one of these peaceful clouds. This disturbance could be the shock wave from a nearby supernova, a star exploding at the end of its life. Whatever the cause, this jolt creates ripples within the cloud. It causes denser pockets of gas and dust to form. Once these pockets appear, a fundamental force of the universe takes over gravity. As the clump of gas and dust continues to collapse, it starts to heat up. This is a basic law of physics. When you compress a gas, its temperature increases. The core of the clump becomes hotter and hotter, and denser. At this stage, the object is not yet a true star. It is what astronomers call a protostar, a sort of stellar embryo. Eventually, a critical point is reached. The hydrogen atoms at the very heart of the protostar are squeezed together with such immense force that they fuse together to form helium. This process is called nuclear fusion. The moment nuclear fusion begins is the moment a protostar is officially born as a star. This is the spark of life that will power it for the rest of its existence. Once a star is born and begins to shine, its entire future is already set. The most important factor that determines a star's life story is its mass. This single property, mass, dictates how hot a star will be, what color it will shine, how bright it will be, how long it will live, and even how it will eventually die. Low-mass stars, those with less material than our sun, are actually the most common type in the universe. Because they have less mass, their gravity is weaker. This means the pressure and temperature in their cores are lower. High-mass stars are the giants of the stellar world. Their immense mass creates extreme gravitational pressure, leading to incredibly high temperatures in their cores. They burn through their hydrogen fuel at a furious, almost wasteful pace. When we think of stars, we often imagine brilliant, powerful suns like our own. But actually, the most common type of star in the universe is much smaller, cooler, and dimmer. These are the red dwarfs, the quiet, unassuming members of the cosmic family. They're true lightweights, typically having between 8 and 50% of the mass of our sun. Because of their small size and low mass, the force of gravity pressing down on their cores is much weaker. They're incredibly dim, so dim in fact that not a single red dwarf is visible to the naked eye from Earth, even though they are our cosmic neighbors. The closest star to our sun, Proxima Centauri, is a red dwarf. One of the most astonishing facts about red dwarfs is their incredible lifespan. A typical red dwarf can live for trillions of years. This means that every single red dwarf that has ever been created is still shining today. Now, let's turn our attention to a completely different kind of dwarf star, one that represents an ending rather than a beginning. A white dwarf isn't really a star in the traditional sense because it's no longer generating energy through nuclear fusion in its core. Instead, it's the hot, dense leftover core of a star that was once like our sun. It's the stellar corpse of a once mighty star, a ghost glowing in the cosmic graveyard. A white dwarf is an object of extremes. It packs a huge amount of mass into a very small space. A typical white dwarf has about the same mass as our sun, but it's squeezed down into a volume roughly the size of the Earth. When a white dwarf is first formed, it's incredibly hot, with surface temperatures exceeding 100,000 degrees Celsius. But with no internal energy source, a white dwarf is simply radiating away its leftover heat into space. Though they are small, dwarf stars actually hold the keys to understanding some of the biggest questions in astronomy. They are not just single points of light. They're like cosmic laboratories that allow us to test the laws of physics under really extreme conditions. Red dwarfs, with their incredibly long lives, give us a window into the very distant future of the universe. White dwarfs, on the other hand, tell us about both the past and the future. They act as cosmic clocks, ticking away as they cool down over billions of years. Dwarf stars also play a crucial role in creating some of the most spectacular events in the universe. Sometimes a white dwarf is not alone, but is in a binary system orbiting another star. This material builds up on the white dwarf surface until it reaches a critical temperature and pressure. This event, called a nova, causes the star to brighten dramatically for a short period. It's a powerful reminder that even a dead star can have a surprisingly violent and active life. After a long and stable life on the main sequence, some stars are destined for a dramatic transformation. This is what happens to medium-mass stars like our Sun and even more massive ones. This grand change starts when the star exhausts the hydrogen fuel at its very center. For billions of years, the outward pressure from nuclear fusion has perfectly balanced the inward crush of gravity. But when the fuel runs out in the core, that balance is broken. Gravity begins to win the fight, and the core starts to collapse under its own immense weight. This core collapse is the trigger for a remarkable chain of events. As the core, now made mostly of helium, shrinks and compresses, it gets incredibly hot. The temperature in the region just outside the core skyrockets. It gets so hot that a new shell of hydrogen around the core begins to fuse. This flood of new energy pushes outward with immense force, causing the star's outer layers to expand dramatically. Red giants are perhaps the most famous type of giant star, and they offer us a direct preview of our own sun's distant future. In about 5 billion years, our sun will run out of hydrogen in its core and begin its transformation. It will swell up, expanding past the orbit of Mercury, then Venus, and possibly even engulfing our own planet, Earth. The familiar yellow-white star that has nurtured life for billions of years will become a colossal, luminous red giant. One of the most well-known red giants in our night sky is the star Aldebaran, the fiery eye of the constellation Taurus, the bull. Aldebaran is about 65 light-years away and has a diameter roughly 44 times that of our sun. Life as a red giant is a complex and dynamic process. After the core collapses and the hydrogen shell ignites, the helium core continues to contract and heat up. If the star is massive enough, the core will eventually reach a temperature of about 100 million degrees Celsius. While red giants represent the old age of medium-mass stars, there is another category of giant stars that are quite different, the blue giants. These stars are not old and bloated. They are young, hot, and incredibly massive. A blue giant is a main sequence star, but one that was born with a huge amount of mass, typically between 10 and 100 times the mass of our sun. Their immense mass creates crushing pressure and extreme temperatures in their cores. This furious fusion makes them incredibly luminous and gives them very high surface temperatures. These high temperatures, often exceeding 20,000 degrees Celsius, are what make them shine with a brilliant blue or blue-white light. However, this extravagant lifestyle comes at a great cost. While our sun will live for about 10 billion years, a blue giant will exhaust its fuel in just a few million years. They live fast and die young, making them a rare sight in the cosmos. Beyond the dwarfs and even the giants, there exists a class of stars that defies imagination. These are the supergiants, the absolute titans of the cosmos. They are the most massive and most luminous stars in the entire universe. The size of a supergiant is truly mind-boggling. If you were to replace our Sun with a typical red supergiant, it would not just swallow Mercury, Venus, Earth, and Mars. It would extend far beyond the orbit of Jupiter. Supergiants come in different colors, just like other stars. Blue supergiants are incredibly hot, young, and compact, representing an early phase for these massive stars. Red supergiants, on the other hand, are cooler, but are the largest stars in the universe by volume. These colossal stars are exceedingly rare. For every supergiant, there are millions of smaller, more modest stars, like our Sun, or the countless red dwarfs. Finding and studying them is like finding a precious gem. The life of a supergiant is a constant, violent struggle. It is a life lived on the edge, defined by a furious rate of energy consumption. Because of their immense mass, the gravitational force trying to crush the star is astronomical. To counteract this, the star's core must burn through its nuclear fuel at a truly prodigious rate. The temperatures and pressures in the core of a supergiant are so extreme that they burn through their initial hydrogen supply in just a few million years. Once the hydrogen in the core is gone, a supergiant embarks on a frantic sequence of fusion stages. Gravity crushes the core, causing it to heat up until it is hot enough to fuse helium into carbon and oxygen. This phase lasts for an even shorter time. This frantic fusion process creates a unique structure within the supergiant, resembling a cosmic onion. At the very center is the final product of fusion, and surrounding it are concentric shells where different, lighter elements are still burning. To make the idea of a supergiant more concrete, we need only look to our own night sky. One of the most famous and fascinating supergiants is Betelgeuse, the bright, reddish star that marks the right shoulder of the constellation Orion. Betelgeuse is a red supergiant, a true behemoth of a star. It is relatively close to us, about 650 light-years away. It is so large that, if it were at the center of our solar system, its surface would extend out past the asteroid belt. Betelgeuse is a star in its final throes of life. It has already exhausted the hydrogen in its core and has swelled into its current red supergiant form. Scientists know that Betelgeuse is a ticking time bomb. At some point in the relatively near future, astronomically speaking, its core will collapse and it will explode as a supernova. When it does, it will be the most spectacular celestial event in recorded human history. Every star, no matter how large or small, must eventually face the end of its life. The story of a star is a constant duel between two mighty forces. There is the relentless inward pull of gravity, trying to crush the star into an infinitesimally small point. And there is the immense outward pressure generated by nuclear fusion in its core, pushing back against that collapse. For as long as a star has fuel to burn, these two forces remain in a delicate balance. But when the fuel runs out, that balance is shattered forever. For low to medium mass stars like our Sun, the end is a relatively gentle and beautiful affair. After their red giant phase, where they fuse hydrogen and then helium, they simply do not have enough mass to ignite the heavier elements. The star's outer layers, which have become unstable, drift away peacefully into space. They form a stunning, glowing cloud of gas and dust, known as a planetary nebula. For stars born with much more mass, the end is anything but gentle. When a high-mass star, one with more than about 8 times the mass of our Sun, runs out of fuel, gravity's victory is swift and catastrophic. The star's iron core collapses in less than a second. The resulting shockwave rips the star apart in a titanic explosion called a supernova. But what happens to the core itself? For some, the collapse is halted, creating one of the most extreme objects in the universe, a neutron star. During the core's collapse, the pressure is so immense that it overcomes the forces that keep atoms apart. The entire core is crushed down into a sphere only about 20 kilometers across, the size of a city. This is a neutron star. It is so dense that a single sugar cube-sized piece of it would weigh more than all of humanity combined. But what if the original star was even more massive? When its core collapses, there is so much mass that nothing can stop it. Not even neutron degeneracy pressure is strong enough to hold back the final, ultimate crush of gravity. The core collapses completely, shrinking past the point of being a neutron star. It continues to collapse until it forms a black hole, an object with gravity so powerful that nothing, not even light, can escape its grasp. The death of a massive star is honestly the most dramatic event in the universe. The supernova explosion that marks its end is an event of almost unimaginable power. For a few weeks, that single exploding star can outshine its entire home galaxy. The energy released in just a few seconds is more than our sun will produce in its entire 10 billion year lifetime. This colossal blast sends a shockwave racing outward into space at incredible speeds. But these explosions aren't just for show. They're fundamentally important to our existence. The universe started out with only the lightest elements. It's only in the extreme conditions of a supernova explosion that the heaviest elements can be formed. The gold in your ring, the silver in your coins, the uranium in a power plant. All of it was forged in the heart of a supernova that exploded billions of years ago. We are quite literally made from the ashes of exploded stars. We've traveled on an incredible journey across the cosmos, from the cold, dark stellar nurseries where stars are born to the spectacular explosions that mark their deaths. We've explored the vast and diverse families of stars that populate our universe. We met the humble red dwarfs, the most common stars of all, sipping their fuel so slowly that they'll outlive all others. We saw the future of our own sun in the creation of a dense white dwarf, the glowing ember left behind after a long and stable life. And finally, we stood in awe of the supergiants, the true titans of the cosmos. These colossal stars live short, violent lives, forging the heaviest elements before ending in supernova explosions that seed the universe with the building blocks of new worlds. Every single star is a character in the grand cosmic narrative. This journey has shown us that the night sky isn't just a random scattering of twinkling lights. It's a dynamic, evolving ecosystem on the grandest possible scale. For all that we've learned about the lives of stars, our journey of discovery is far from over. In fact, every new answer we find seems to open up a dozen new and even more fascinating questions. What happens inside the impenetrable core of a neutron star, where matter is crushed to unimaginable densities? How exactly does the complex mechanism of a supernova explosion work to create and eject the heaviest elements? We know that many stars have planets, but how many of them might harbor life? Could life exist on a planet orbiting a long-lived red dwarf, surviving its powerful flares? And then there's the puzzle of dark matter and dark energy. The stars are our primary tool for probing these great unknowns, their light carrying clues across billions of light years. The adventure has only just begun. As we conclude our stellar tour, I hope you look up at the night sky with a new sense of wonder and connection. Every point of light has a story. That faint reddish star might be a red dwarf, a neighbor that will shine for trillions of years. That brilliant blue-white spark could be a distant giant, living a short and spectacular life. And remember, the light from these stars has traveled for years, decades, or even centuries to reach your eyes. You're literally looking into the past. This knowledge doesn't make the universe feel distant or abstract. On the contrary, it connects us to it in the most intimate way possible. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all of these atoms were forged in the heart of a massive star. That star exploded as a supernova, scattering its precious life-giving elements across the galaxy. This material eventually came together to form our sun, our planet, and ultimately you. You are, in the most literal sense, made of stardust. You are a child of the cosmos. So, the next time you find yourself under a clear, dark sky, take a moment. Find a familiar constellation like Orion and see the story written there. See the reddish glow of the supergiant Betelgeuse nearing the end of its life, and contrast it with the brilliant blue-white light of the young giant Rigel. Realize that you're seeing stellar evolution in action, two stars at completely different stages of their existence. The universe is not something that's just out there. You are a part of it, and it is a part of you. You are a way for the cosmos to know itself. I encourage you to stay curious, keep asking questions, read more, watch documentaries, or maybe even get a small telescope and see these celestial wonders for yourself. The universe is full of incredible beauty and mind-boggling phenomena. By exploring the stars, we explore our own origins and our place in this vast and magnificent reality. The story of the stars is our story, A tale of cosmic fire and dust that connects every one of us to the grandest spectacle of all. Keep looking up.